Hi there, and welcome to the Lean Design Simulator demo. Thank you for your interest in this powerful simulation modeling tool. And we could spend a lot of time on this, but I know you just probably want a quick overview. So let me share with you basically how it works and some of the key features. And there'll be plenty of opportunity to dive into the details in the future if you're interested in pursuing the use of this really great tool. So basically, the inputs and the outputs of the simulator are done in a software package that you already are familiar with, most likely, which is Excel. So you enter your data into a series of Excel worksheets, and you'll also review the output of the simulator in Excel. And then in between those two steps is essentially a black box, which is the Lean Design Simulator engine, which does the processing of this data and then returns to you an Excel file with that. With the results. So let me click through the various tabs of the data entry side of the Lean Design Simulator so you can get a feel for what kind of data is required. First one is called flow description, where you're defining the number of routings in your model. So in this example, we have a final assembly line. That's the main line. And then you can have a high number. There's a limit somewhere, but I'm not sure what it is, of subassemblies if you want to define those. So this is where you define the names of those. The resources sheet lists the resources required in your design. Resources like workstations, machines, people of various labor categories, and then secondary resources like conveyance devices, AGVs, fork trucks, etc. Those are all defined in this sheet. The flow sheet defines the relationship of those resources. So which comes first, which comes second. You define basically the flow or the map where you define the starting resource and then the next location. And you can split that location with percentages. You can define quite complex flows, but it's all done here on this sheet. Next one is product. So these are the entities that are flowing through your simulation model. It could be products or it could be information. It's basically the value that's flowing through your value stream. In this example, we have 6 products and 1 subassembly product. All those are defined here, and the flows that they are built in or go through. And this is the process time sheet where you define for each product and station, so each product and resource, the machine time, if any, labor time, and also the number of operators that are required before work can be done at that station. And finally, this is the sequence worksheet. This lists the products that we're going to want to run through the model, how many at a time, and we also document here which subassemblies are required. So in this example, when we run product 1, we're going to run 1, and we need to also be consuming subassembly 1 at the same time. And if you have more than one subassembly, you simply list them here by adding columns to this worksheet. So that's all you need to have. Now let's jump over to the simulator itself and show you how this works. So the simulator is a built-in function or feature of the Lean Design Studio. Lean Design Studio has all kinds of other things like foundation skills training. These are extensive courses in mixed model line design and mixed model material management. We have the simulator, which I'll show you immediately. Advanced topics, all kinds of specialized topics related to mixed model line design. Mastermind is a forum for you to ask questions and share comments. And then we have a roadmap or series of checklists to implement mixed model line design and mixed model material management, a step-by-step guide to doing that. So let's go to the simulator. And as I said, we've black boxed the simulator to make it extremely easy. So what we need to do is load the input file right here. So it's called Lean Design Simulator Validation, Data Validation. That's the model we're currently working with. Now you can validate it. The validation also can take place in Excel. So we have kind of a double check here to make sure there are no errors in your data. But when you run simulate, it also checks the file. So we have really 3 levels of checking. And by clicking on the simulate button, then it's going to prompt for some parameters, and then we're going to run the file. The 2 parameters you need to enter are warm-up time. That's the time to wet the line or fill the line. And I'm going to enter 100 minutes. And then the run time, how long do you want to run in simulation minutes? So I'll enter 1,000 just for the test. You can turn on and off variability of the times with this checkbox, and that's it. So that's all you need to run the simulation. It's going to take the Excel file that you created and it's going to process it in simulation time. And this is actually running in your browser. Done. And we completed 150 units. So is that good or bad? Well, we don't really know. We need to look at that data, and so you can download the results. The results are created in another Excel file, a separate Excel file, and this will allow us to take a look at actually what happened. So here is the results file. We completed 150 units. Here are the units that we scheduled. Here are the units that we were able to complete within those 1,000 minutes. And then we can look in detail at the order statistics. This is a list of every individual product that went through this model, including the subassemblies, when we started it, when we finished it, and you can kind of get an idea, a very accurate idea of the throughput time there. And then this is really the most important sheet. It's the resources statistics sheet. I'm going to auto-fit the columns a little bit. So on this sheet, we can analyze how many entries for each individual resource and what percent that resource was working, what percent they were waiting. So waiting is I'm ready to work, but there's something that's preventing me from working. There was not much waiting of that type here. Percent blocked, and then percent idle, where I'm available, but I have nothing to work on. So this is the kind of analysis we would have to do. We look at percent busy, we look at where the bottlenecks are, and we look at the utilization of these operators. So we have 5 final assembly operators and utilizations in the 40% range in this case, so not the best. So this is the main sheet that we would look at to analyze the output and determine what kind of improvements we could make to either improve the throughput, improve the utilization, improve the productivity of the operators. And we would conduct a series of experiments where we make changes to the model, rerun it, look primarily at this sheet right here, and look at throughput, and then make modifications. The kind of modifications we might make would be changes to the flow, if possible, reducing time, if possible, adding buffers or in-process Kanbans where appropriate, and conducting a series of experiments. You can see it only takes really a few seconds to make those modifications and rerun the model. So we want to be able to conduct a whole series of process improvement experiments to validate our original design and make improvements to it. So when it comes to actually implementing this design, we want to make sure that design is extraordinarily lean to begin with, and so that it doesn't require a lot of quote-unquote Kaizen after the fact. The only Kaizen that your design should require after the fact are small continuous improvement ideas. It should not require any big modifications because you're not meeting your throughput or not meeting your productivity goals. So simulation modeling is incredibly important and powerful in that regard. So I think I hope that gives you a quick overview of the Lean Design Simulator. There's clearly a lot more that we could say about it, but that's our quick introduction for the moment. Thanks.